Apache OpenNLP, a comprehensive guide to setup and core functionalities. Apache OpenNLP is a robust machine learning-based toolkit engineered for processing natural language text. It offers a comprehensive suite of tools for common natural language processing tasks, making it a valuable asset for developers and researchers aiming to integrate linguistic intelligence into their applications. The library's design emphasizes efficiency and ease of integration into Java environments, positioning it as an ideal choice for developing lightweight NLP-powered solutions, particularly in areas such as intelligent chatbots and automated text analysis. Setting up OpenNLP is a straightforward process that involves satisfying basic Java development environment requirements and integrating the library using standard build automation tools like Maven or Gradle, or through a direct binary distribution. Its modular architecture allows users to leverage specific functionalities as needed, providing flexibility for diverse project requirements. Apache OpenNLP is an open-source, machine learning-based toolkit specifically designed for natural language processing tasks. Developed under the Apache Software Foundation, it is predominantly written in Java, with approximately 97.5% of its codebase in this language, making it a natural fit for Java-centric development environments. The toolkit provides a collection of pre-trained models and utilities that empower applications to comprehend and extract meaningful information from unstructured text data. Its design prioritizes efficiency, rendering it highly suitable for small to medium-scale applications where performance and resource utilization are key considerations. OpenNLP supports a wide array of fundamental NLP tasks, each serving as a critical step in the comprehensive analysis and understanding of text. Sentence detection. This component identifies sentence boundaries within a given text. It can discern whether a punctuation mark signifies the end of a sentence. Tokenization. Following sentence detection, tokenization breaks down sentences into individual words, punctuation marks, or other meaningful units, known as tokens. Lemmatization. This functionality reduces words to their base or dictionary form, known as a lemma. For example, running, ran, and runs would all be reduced to run. Part of speech tagging, the POS tagger assigns grammatical categories like noun, verb, adjective, adverb to each token based on its context within the sentence. Named entity recognition. NER identifies and classifies named entities present in text, such as names of people, organizations, locations, dates, and numerical expressions. Chunking, also known as shallow parsing, chunking groups words into syntactically correlated parts such as noun phrases or verb phrases. Parsing. This component analyzes the full grammatical structure of sentences, typically producing parsy trees that illustrate the syntactic relationships between words and phrases. Language detection. This feature automatically identifies the natural language in which a given text is written. Coreference resolution. This advanced functionality determines when different expressions in a text refer to the same real-world entity, helping to build a coherent understanding of discourse. A clear overview of these capabilities is presented in the table below. Sentence detection identifies boundaries of sentences in text. Tokenization breaks text into individual words, punctuation, etc. Lemmatization reduces words to their base or dictionary form. Part of speech tagging assigns grammatical categories to tokens. Named entity recognition identifies and classifies named entities. OpenNLP is extensively used by developers and researchers to build intelligent applications that interact with human language. It plays a pivotal role in the creation of intelligent chatbots, particularly for lightweight and small to medium-scale applications. The toolkit's versatility allows for a wide spectrum of text analysis applications, including sentiment analysis, document classification, information extraction. OpenNLP is designed for straightforward integration into Java applications, offering simple and intuitive APIs. OpenNLP provides the flexibility to train custom models for domain-specific requirements. When selecting an NLP library for Java development, Apache OpenNLP and Stanford NLP often emerge as leading contenders. Apache OpenNLP is recognized for its simplicity and lightweight nature, offering a less demanding learning curve. In contrast, Stanford NLP is characterized by greater complexity and a steeper learning curve. The decision between these two powerful toolkits is a strategic one, directly influencing the project's development timeline. Before proceeding with the installation and setup of Apache OpenNLP, it is imperative to ensure that the development environment meets the necessary prerequisites. To compile and execute OpenNLP applications, a minimum of JDK 17 is required. A critical aspect involves correctly configuring the Java_home environment variable, and including the bin directory in your system's path variable. For developers planning to build OpenNLP from its source code, or integrate it as a dependency within a Java project using Maven, Apache Maven version 3, 3.9 or a more recent version is a mandatory requirement. Maven serves as a powerful build automation tool that significantly simplifies dependency management, project compilation, and the overall build lifecycle, streamlining the development process for Java applications. While not a direct prerequisite for compiling OpenNLP itself from source, Gradle is another widely adopted build automation tool within the Java community. If the intention is to integrate OpenNLP into a Gradle-based project, ensuring a recent and compatible version of Gradle is installed is necessary for effective dependency resolution and project management. Given that OpenNLP is developed in Java, it inherently possesses cross-platform compatibility. Its binary distributions are provided in tar.gz format, commonly used on Linux and Unix-like operating systems, and .zip format, which is standard for Windows environments. This availability across different archive types underscores its broad operating system support. The consistent and strong emphasis on specific Java development kit versions and Java build tools like Maven and Gradle throughout the OpenNLP documentation indicates a deeper requirement than merely having the software installed. It signals that OpenNLP is deeply embedded within the Java development ecosystem. Apache OpenNLP offers flexible setup options, allowing users to choose between a direct binary distribution for command line operations or integrating it as a dependency within Java projects using build automation tools like Maven or Gradle. This method is particularly suitable for quick demonstrations, testing, or executing command line processing tasks. Begin by navigating to the official OpenNLP releases page, accessible at https://openNLP.apache.org/download.html. From this page, download the latest official release. For Windows users, the Apache OpenNLP 2 5.5-bin.zip file is appropriate, while Linux/Unix-like systems typically use Apache OpenNLP 2 5.5-bin.tar.gz. After downloading, it is a recommended security practice to verify the integrity of the package. This can be done using the provided SHA-512 checksum and ASC signature files. To verify the SHA-512 checksum, use the command gpg printmd SHA-512 filename.tar.gz. Extract the contents of the downloaded .zip or tar.gz file to a chosen directory on your system. Common choices include c.openlp home on Windows or /opt/openlp home on Linux. The OpenNLP command line script relies on specific environment variables for proper execution. Set the OpenNLP_home environment variable to the root directory where you extracted the OpenNLP binary distribution. Subsequently, add %OpenNLP_home%bin for Windows or $OpenNLP_home/bin for Linux Unix to your system's path variable. This addition enables you to invoke the OpenNLP command directly from any directory in your terminal. To confirm a successful installation, open a new command prompt or terminal window. Type OpenNLP and press enter. If the setup is correct, the output should display the current OpenNLP version along with a list of all available command line tools. For Java development, integrating OpenNLP via Maven is the preferred method for managing dependencies and automating project builds. Step 1. Create or open a Maven project. Ensure that your project has a pom.xml file, which is the core configuration file for Maven projects. Step 2. Add OpenNLP dependencies. Within the dependencies section of your pom.xml file, add the necessary OpenNLP artifacts. Typically, OpenNLP tools is required for the core functionalities, and OpenNLP tools models is included if you wish to have pre-trained models bundled directly with your project. Depending on specific project requirements, additional optional dependencies can be included. OpenLPDL for deep learning functionalities, OpenLPDel GPU for GPU accelerated deep learning, OpenLP UIMA for UIMA annotators, or OpenLP morphologic add-on for the morphologic add-on. When working with the latest development version, Snapshot, it is also necessary to add the Apache Snapshot repository to your pom.xml to resolve these dependencies. Step 3. Build your project. Execute mvn clean install or mvn compile from your project's root directory. This command will download all specified OpenNLP dependencies and build your project. Similar to Maven, Gradle offers a robust mechanism for managing OpenNLP dependencies within your Java project. Step 1. Create or open a Gradle project. Ensure your project includes a build.gradle file which defines the project's dependencies and build logic. Step 2. Add OpenNLP dependencies in your build.gradle file. Add the desired OpenNLP dependencies within the dependencies block. As with Maven, optional dependencies like OpenNLP-DL, OpenNLP-DEL GPU, OpenNLP-UEMA, and OpenNLP Morphologic add-in can be added as implementation dependencies. For snapshot versions, the Maven snapshot repository must be added to your Gradle configuration. Step 3. Sync Gradle project. Refresh your Gradle project within your Integrated Development Environment, IDE, or execute Gradle build from the command line to download dependencies and build the project. The provision of comprehensive instructions for Maven and Gradle integration, alongside the simpler binary download, underscores a fundamental design principle. OpenNLP is engineered for integration into larger, more complex Java applications. Utilizing build automation tools such as Maven or Gradle for dependency management is not merely a convenience. It represents a critical practice for ensuring the scalability, maintainability, and reproducibility of a project. These tools autonomously resolve transitive dependencies, manage versioning conflicts, and standardize the build process across diverse development environments. Relying solely on manual binary setup, while expedient for initial testing, can lead to complex class path issues, versioning conflicts, and significant challenges in collaborative development or deployment to production environments. Consequently, the chosen integration method directly impacts the long-term health and robustness of any application powered by OpenNLP. For serious development efforts, integration via Maven or Gradle is inherently the more robust and recommended approach. The table below outlines the essential Maven-Gradle dependencies for Apache OpenNLP, working with pre-trained models. Apache OpenNLP, as a machine learning-based toolkit, fundamentally relies on models to execute its NLP tasks. These models encapsulate the intricate patterns learned from extensive text data, enabling the toolkit to accurately process and interpret new input. Understanding OpenNLP models. OpenNLP provides a diverse array of pre-trained models tailored for common NLP tasks across numerous languages. These models are indispensable for the toolkit's operation, as they contain the statistical or machine learning algorithms that have been trained to perform specific linguistic analyses, such as identifying sentences or recognizing named entities. Each core NLP component, including the sentence detector, tokenizer, and POS tagger, typically necessitates a specific model file, for example n-sent.bin, n-token.bin, to function correctly. Pre-trained models are readily available for download from the official Apache OpenNLP models page, https://openNLP.apache.org/models.html. The project offers a generic model for language detection, alongside 36 language-specific models designed for tasks such as sentence detection, tokenization, lemmatization, and part-of-speech tagging. For instance, to perform English sentence detection, one would download the OpenNLP-n-ut-sentence-1.3-2.5.4.bin model file. For convenience, many of these models are also bundled within jar files distributed via Maven Central, particularly those for sentence detection, tokenization, lemmatization, and POS tagging, which simplifies dependency management for users leveraging Maven or Gradle. The table below lists some commonly used Apache OpenNLP pre-trained models. Loading a model is a prerequisite step before performing any NLP task using OpenNLP's Java API. The standard procedure involves creating an input stream from the model file and then passing this stream to the constructor of the relevant model class. A critical programming practice is to always use a try with resources statement when handling input stream objects. This ensures that the resource is automatically closed even if exceptions occur during the model loading process, thereby preventing resource leaks and enhancing application stability. Example: loading a sentence detection model. The pervasive requirement for models signifies that OpenNLP's architecture is fundamentally model-driven. Its reliance on machine learning means that its core functionalities are powered by statistical models trained on extensive datasets. The OpenNLP binary distribution includes command-line tools that facilitate direct interaction with models for text processing. The general usage involves invoking the OpenNLP script, followed by the specific tool name and the path to the model file. First, ensure that the en-sent.bin model has been downloaded and placed in an accessible location, such as within your OpenNLP_home/models directory. This section provides practical demonstrations of how to implement the most common NLP tasks using OpenNLP's Java API. Each example adheres to a consistent pattern. Load the appropriate pre-trained model, instantiate the corresponding OpenNLP tool, and then apply it to the text data. The primary objective of sentence detection is to accurately identify and segment a raw block of text into individual sentences. Implementation. Load the sentence detector model. Instantiate the sentence detector me detect sentences. Alternatively, obtain sentence positions as spans. Tokenization serves the purpose of breaking down sentences into their constituent individual tokens, which can include words, punctuation marks, or numerical figures. Implementation. Load the tokenizer model, instantiate the tokenizer me, tokenize the sentence. Alternatively, obtain token positions as spans. The aim of POS tagging is to assign appropriate grammatical tags, for example, noun, verb, adjective, to each token within a sentence. This operation typically requires the input text to have already undergone tokenization. Implementation. Load the POS tagger model, instantiate the post-tagger me, tag the tokens. Named Entity Recognition, NER, focuses on identifying and classifying named entities such as persons, locations, and organizations within a given text. Like POS tagging, this task